Hi, science friends. Let's pick back up here where we left off yesterday when Miss Linda came in and we picked back up with our roller coasters. So we were talking about efficiency of machines. So I believe when we were left off, I'd ask you when you are raising a sail, if you're using a pulley to raise a sail on the sailboat, where do you lose energy from, right? So we have the amount of work that we actually have to put into raising that sail. But then we have an amount of work that is going to be actually used to raise the sail. And those numbers are not the same. So I think that you all told me some of the energy is lost to friction. All right. So let's say it takes 1,000 joules of energy to actually lift the sail. That's just for the sail, okay? That does not include whatever you're going to lose to friction or any of those types of things. So the input that you have to put in is actually going to be more than 1,000 because it's going to compensate for that energy that you're going to lose to friction and other things, which we're going to talk about in just a second, okay? So the input is always bigger, if you may want to write this down, than the output. Okay? The input is always bigger, the output is always smaller. So the efficiency is always going to be less than 100. So that should really help you a lot with your calculations because you know if you get something greater than 100, then you flipped those two. So switch it up and do it right the second time, okay? So let's go back to this sail. There's energy lost to friction, okay? There's also energy lost to the weight of the rope. If it takes 1,000 joules of energy just for the sail, you're also having to put in some energy to compensate for the weight of the rope. You're losing energy to vibration. You know, when you pull something through a pulley, it kind of vibrates and it swivels, and that pulley will squeak. And so there's actually a little bit of energy lost to sound. So these might seem like very small amounts or negligible, but it is extra work that you are having to put in that's not technically getting transferred to the sail. And so that reduces the efficiency of the pulley, which is the machine in this case. Okay, the pulley was one of our 6 simple machines that we talked about. So let's do a couple of calculations with this. You have a worksheet that you're going to work on today that just has maybe 5 or 6 problems on it. It says conservation of energy worksheet. You should have one of those in your binder. If for some reason you can't find yours, I did leave a few extra with the sub. So make sure to grab one of those and finish that today. That should be turned in today, okay? So let's look at a couple of these in practice together, and then you'll have a few to try on your own. Alice and Jim calculate that they must do 1,800 joules of work to push a piano up a ramp. However, because they must also overcome friction, they actually do 2,400 joules of work. So what is the efficiency of the ramp? So I've written the formula up here. The useful work output, okay, is going to be this. This is our useful work. That's what we're actually trying to do. You have to have 1,800 joules just to get the piano up the ramp, okay? But the input, which is going to include for friction and all of those other energy pieces that are lost, is 2,400 joules, okay? So if you divide that, 1,800 divided by 2,400, then you get 0.75, okay? So this is going to be 0.75, or we would say 75% efficient. And that is how you would work that calculation, okay? Again, that was our right answer because it's less than 100. Our big number went on the bottom, our small number went on the top, just as we talked about. Let's look at the next one. A windmill has an efficiency of 37.5%. So that's our efficiency. We're going to have to convert that to a decimal, though. So that's going to be 0.375 equals. If a gust of wind does 125 joules of work on the blades of the windmill, how much output work can the windmill do as a result of the gust? So our output is what's going to go on top. That's what we're trying to find, okay? The gust of wind, the work that's actually put in, is the 125 joules. So we're going to multiply 125 joules times 0.375. And get 46.9 joules. And that is the output, okay? So that's what it would be if it were 37.5% efficient. Again, that's going to be this number that's going on top, which is going to make it smaller than the number that we had on the bottom, okay? So you have 2 more to practice, so pause me here, practice those 2, and then come back and check your answer with me. So on the first one, you should have got 4,800 joules. And on the second one, you should have gotten 60.7% efficient. Okay? So I've worked those 2 problems there. Hopefully you got those pretty easily. Go ahead and complete the conservation of energy worksheet from your binder. That's the last real assignment for this unit. And then after you do that, you can go ahead and start working on the study guide. Hang on to your study guide. Don't turn those in. Keep those to be able to use, and you can turn those in on the test day, which will be Tuesday. But the conservation of energy worksheet, please turn that in today to the sub before you leave. Okay? So when I return on Monday, we'll do a review, and then your test will be on Tuesday. If you all have any questions, you can email me. I'm at Central Office all day doing professional development. But I hope you all have a great day and a great weekend.